In this video, we're going to see another useful operation, and that is to copy two arrays or copy one array into another array. So let's say we've got this array. We're going to say integer array, I'll call it array 1 equals, and let's initialize it with a few values. So I'm going to say 2, 4, 6, 8, and 10 again, like the previous example. And now we've got an array with values 2, 4, 6, 8, 10. So it's of size 1, 2, 3, 4, 5 again. That's the size 5. And we've got the values 2, 4, 6, 8, 10 in positions 0, 1, 2, 3, and 4. Now let's declare a second array, and we want to have that array have the exact same values as the one at the top. So you agree that I can just say array 1, or can we? If you remember, when comparing arrays, we talked about memory locations here. So if I say int array 2 equals array 1, what am I copying? Am I copying the values there? Or am I just saying that array 1 and array 2 should point to the exact same object? I didn't make a copy of the object, I'm pointing to the exact same object. So this is a way of not copying two arrays. And let me just show you when we print this out. So let's say system out print line. Well, instead of just having a print line method, let's just create our own method quickly here. So I'm going to say public static void, and let's call this one print array. And for this print array, I'm going to pass in, and now we can just quickly have a look at methods also when we're passing in array. So we can say int array and call this one, let's just call it array there. And then we're going to take this array, the value that was passed in the array, and we print it out. So you remember that enhanced for loop, where we just get the value from the specific array that was passed in, and it will print out those values for us. So I'm going to say system out print line, and I will just print out the value there. So now by calling this method print array, and I pass in an array of type int, it will go and say, well, let's take from this array position 0 and place it into value, and then we print it out. The next time it runs, it will take position 1 of the array and place it into value, and so forth. That's just the enhanced for loop. So now, if I want to print out my array, I can just call print array and pass in, let's pass in array 1 there. And then let's use a system out print line to put a gap between the two printouts. And then I'm going to use the same method again, and let's print out array 2 now. So if we do that, let's run it from here. So you'll see the values are exactly the same. It's 2, 4, 6, 8, 10 and 2, 4, 6, 8, 10. It's because essentially these two are pointing to the exact same array. So let's say I'm going to say array 1 at position, let's say 1, should not be, you can see that array 1, this one at position 1 is the 4. So let's change the 4 to a 5 there and see how it prints out now. So if I run this now, array 1 should now be a 5 at position 1. So let's see the printout. You can see, yeah, it changed to a 5. But look at the bottom one, it also changed to a 5. So this is again just confirming what I said, that both array 1 and array 2 is pointing to the exact same object. So if I change something in array 1, it will be essentially changed for array 2 as well. And that's not what we want. Okay, so this is the way of not copying two arrays. Right, so let's take that away. So step number 1, what we want to do is to create an array of the exact same size as the one we want to copy. So I can see that the size here is 5 by just counting them 1, 2, 3, 4, 5 values. But in coding, normally you can't see the size, and your sizes could be fixed or not. Could be a size of 10 or 15 or whatever that you know, but it can also be a size that you don't know. So the best way of doing this is to say new int, create a new array, but we're going to set this size. Instead of passing in 5 there, if you don't know the size, we'll just passing array 1.length. And that will give us the same size. So now the two arrays, there's array 1 already declared and initialized. This one, array 2, is now initialized with a length of 5. And now if I don't set any values, then at position, essentially this array will now look like this. If I don't set values, it will just have zeros there, 0, 0, 0, 0, 0, 0. That will be how the array looks if I don't assign any value. So this one, after this one line, I will have 1, 2, 3, 4, 5 zeros saved in the array. Okay, now we get to step number 2. After setting the array the exact same size as that one, we can now use a for loop. So I'm going to use a normal for loop. There you've got the enhanced one. So I'm just going to use a normal for loop here. So integer I equals 0, I less than, and I can take array 1 or array 2 because they are now of the same length. But let's just take array 1, and then we need to increment using I++ to run through every element. So essentially what we want to do for step number 2 is to take every single value of array 1 and place it into this exact same position in array 2. So we're going to say array 2 at that specific position should be what array 1 is at that same position, which we call I. So now after this for loop, let's just print out these two arrays again. So I'm going to print out array 1. Let's say array 1 there. I'm going to have a simple system out print line to just separate the two with one line. And let's print out array 2 the same way again. So if I run this, obviously it's the same as the previous example. Both will have the 2, 4, 6, 8, 10. But now, the difference is, I can now go to array 1 and go to, let's say, position 1 now and change the 4 there to a 5. And let's run this again, and you can see then that array 1's 4 has been changed, but not the one for array 2. And you can see there, the 4 has been changed to a 5, but that one is still a 4. And in this way, you can see that the two arrays are not pointing to the same object or the same array. We are working with different arrays.